Welcome. Today we're going to learn about solving systems using elimination. Don't forget to get your notebook out and be ready to take notes. Pause the video and set up your Cornell notes with your topic heading at the top, questions on the left-hand side, section 4 for the summary, and section 3 for the main points and concepts. We're going to start by learning about the least common multiple. Let's start with the definition of multiple. Multiple is the result of multiplying a number by an integer. So for example, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, and so on. 2, 4, 6, and 8 are all multiples of 2. If you want to expand that and talk about a common multiple, it's a multiple that two numbers have in common. So multiples of 2 are 2, 4, 6, 8, 10, and so on. Multiples of 3 are 3, 6, 9, 12, 15, and so on. The least common multiple for this would be 6, because 2 and 3 both have a multiple of 6. For our purposes, we need opposite common multiples. Same number, but opposite signs. If I want to make opposite signs and turn these into common multiples, if I want to turn 2 into 6, I need to multiply by 3. So 2 times 3 would be equal to 6. What would I need to multiply 3 by to make negative 6? Well, 3 times 2 would be positive 6, so 3 times negative 2 would be negative 6. So what happens when we add opposite common multiples? So we're going to start by finding opposite common multiples. So let's think about a common multiple of 2 and 4. If I count by 2's, it's 2, 4, 6, 8, and so on. 4, 8, 12, and so on. The least common multiple is 4. So I need to multiply 2 times something to make 4, and I need to multiply 4 times something to make 4. Well, I don't need to multiply 4 times anything. It's already done, so there's no need to multiply 4 times anything. But if I want these to be opposites, if I want them to be negative 4 and 4, I need to multiply by negative 2. When I add negative 4 and 4, I get 0. Let's try that again. Multiples of 3 are 3, 6, 9, 12, 15, 18, and so on. Multiples of 5 are 5, 10, 15, and we've found our common multiple. I need to turn both 3 and 5 into 15. But remember, I need one of them to be a positive 15, and I need one of them to be a negative 15. Well, 3 times 5 would make positive 15. 5 times 3 would make negative 15, so I need to multiply by negative 3 to make that a negative 15. If I add 15 and negative 15, I get 0. Let's find a common multiple of 4 and 8. 4, 8, 12, 16, and so on. 8, 16, 24. I could use 16 if I want to, but the least common multiple is 8. So I'm going to multiply 4 times something and 8 times something to make 8. But remember, I want one of these to be a negative. It doesn't matter which one. I don't need to multiply 8 times anything to make 8. I can multiply 4 times 2 to make 8, but I can turn that into a negative 2, and now I have my opposite common multiple. Notice when we add our opposite common multiples, they eliminate. We are just left with 0 each time. We're going to use that to help eliminate variables in our equations. So let's think about what can be done to eliminate the y term. So we want to think of it like what I've got are negative 5 and 1, and I need opposite common multiples. Well, let's think about what a common multiple of 5 and 1 would be. It would be 5. I need to turn both of those into 5. Well, this one's already a 5, so there's no reason to multiply it times anything. This one is not a 5, so I need to multiply it by 5. They're already opposite signs. This equation just stays the same. 4x minus 5y equals 3. And I multiply everything by 5 using the distributive property. 15x plus 5y equals negative 40. And watch what happens. I can't solve these equations because they have two variables. They both have, I lost my x there. They both have a negative, or they both have an x and a y. But when I add these, that makes 19x. The negative 5y and the positive 5y cancel, and 3 and negative 40 equals negative 37. This is now an equation that I know how to solve because it only has one variable. Let's try that again. What can be done to eliminate y? So I need a common multiple for 2 and 5. Well, a common multiple for 2 and 5, let's see if we can find that first. 2, 4, 6, 8, 10, 5, 10. The common multiple would be 10. I don't multiply by 10. I want to make 10. What did I multiply 2 by to make 10? Well, I multiplied it by 5. What do I multiply 5 by to make 10? I multiply it by 2. These are already opposite signs, so I don't have to worry about multiplying by a negative. This gives me 35x minus 10y equals 15, and 6x plus 10y equals negative 16. If I add these together, I get 41x. The negative 10y and the positive 10y cancel out because that makes 0, and 15 and negative 16 makes negative 1. This is now an equation I can solve because it just has one variable. All right, you're going to want to pause your video and take some notes as we do this. To use elimination to solve a system, step 1 is line up your equation in standard form. Remember, I will help you write down what you need to write down by showing you what to, or I will underline what it is that you need to write down. Number 2, look for opposite common coefficients. It's like negative 2 and positive 2, negative 5 and positive 5. If there are no opposite common coefficients, use multiplication to create opposite common coefficients. Add to eliminate. Solve. Use substitution to find the other solution. And your answer should be an ordered pair. After step 4, this is almost exactly like substitution. These steps right here are the exact same as the second part of solving using substitution. So the difference between substitution and elimination is that we aren't substituting a whole equation into, or excuse me, a whole expression. We are eliminating variables to make these easier to solve. This is a topic that generally feels more complicated to begin with, but most students end up preferring elimination to substitution. So let's try one. Step 1 is to line up our equations in standard form, which these already are. X's are with X's, Y's are with Y's, equals with equals, constants with constants. Number 2, look for opposite common coefficients. Well, X and X are in common. 2X and 2X are the same, but they're not opposite. Here I have negative 3y and positive 3y, so step 2 is done for us. We don't need to do any more. We have negative 3y and positive 3y. Which means in this example, we can skip step 3. We don't need to multiply by anything because we already have opposite common coefficients. Step 4 is add to eliminate. Be careful, we're not subtracting. I'm not taking 2 minus 2. 2x plus 2x is 4x. Negative 3y plus positive 3y is 0, so those disappear, and 8 plus 4 equals 12. Step 5 is to solve for your variable and use substitution to find the other solution. From here on out, this is exactly the set of steps that we used when we did substitution. We divide both sides by 4, so I now know that x equals 3. And I use substitution to find the other solution. So then it doesn't matter which equation I use, I'm going to use the second one. So 2x plus 3y equals 4. I know that x is 3 plus 3y equals 4. That becomes 6 plus 3y equals 6, minus 6 from each side, so 3y equals 0. Divide both sides by 3. Sorry, I'm running out of room, and so y equals 0. And don't forget that your answer should be an ordered pair. So on this one, my answer should be 3, 0. Let's try another one. Step 1 is to line up your equation in standard form. We already have that with this one. 2x and 3x, 3y and 1y. Don't forget there's an invisible 1 there. And 8 and 5 are the constants. Everything's lined up. Look for opposite common coefficients. There are none. 2 and 3 are not the same. 3 and 1 are not the same. So we're going to have to multiply. We need to use multiplication to create them. So let's think about this. I could eliminate the x's. A common multiple of 2 and 3 would be 2, 4, 6, 3, 6. So a common multiple would be 6. But there's an easier way. Look at 3 and 1. A common multiple for 3 and 1 is just 3, which means I don't need to multiply my top equation by anything. It can just stay by itself. I can multiply everything on the bottom, though, by 3. But don't forget, I need these to be opposites. When I add them, I need them to eliminate. So I'm going to multiply by -3. The top equation stays exactly the same, 2x plus 3y equals 8. But the bottom equation, everything becomes multiplied by -3. -9x plus -3y equals -15. I add down. 2 plus -9 is -7x. 3 and -3 cancel out. 8 plus -15 makes -7. That was step 4. Step 5 is to solve. Divide both sides by -7, and so x equals 1. And use substitution to find the other solution. It doesn't matter which of these equations we use. I'm going to use the second one, 3x plus y equals 5. I now know that x equals 1. 3 times 1 is 3, plus y equals 5, minus 3 on each side, and so y becomes 2. Your answer should be an ordered pair. X comes first, so your answer should be 1, 2 there. What about a system like this? What do you notice about this equation? You don't have to use elimination all the time now that you know about it. It's one tool in your toolbox. This problem would actually be better solved using substitution. Why? Well, x is already isolated. This is better solved using substitution because I could just replace x in the other equation with 5 minus y. It could go right there. We can also use this to solve word problems, especially when we notice that we have 2 unknowns. Caesar and Brutus are selling apple pies and lemon meringue pies for a school fundraiser. Caesar sold 6 apple pies and 4 lemon meringue pies for a total of $80. Brutus sold 6 apple pies and 5 lemon meringue pies for a total of $94. What is the cost of each of 1 apple pie and 1 lemon meringue pie? Well, I'm going to use A for the cost of apple pie. Always start by identifying your variables because that's what I want to know about. I like to use a cursive L for my variables. When I use a regular L, it tends to look like a 1 and then I get myself confused. So L is going to stand for the cost of 1 lemon meringue pie. So I'm going to use that to write my equations. I notice that I have 2 totals. I have a total of 80 for what Caesar sold, and I have a total of 94 for what Brutus sold. That means everything about Caesar is going to go in the top equation. Caesar sold 6 apple pies and 4 lemon meringue pies. Brutus sold 6 apple pies and 5 lemon meringue pies. So I've got my system all set up. I'm supposed to look for opposite common coefficients. Well, I have 6 and 6, but I need one of these to be a negative, so I'm going to multiply everything in the bottom equation by -1. The top equation stays exactly the same, 6a plus 4l equals 80. The second equation becomes -6a minus 5l equals -94. We're going to add. 6 and -6 cancel out because that makes 0. 4 take away 5 is -1, so -1l, and 80 plus -94 is -14. I'm going to divide both sides by -1, and so L becomes, L becomes positive 14. I am not done though because I need the cost of not only 1 lemon meringue, but also 1 apple. So I go back to my original equation, 6a plus 4l equals 80. Doesn't matter which one we use, so I used the one with smaller numbers. This becomes 6a plus 4 times 14 equals 80. This becomes 6a. Let's see, 4 times 14 becomes 56. So 6a plus 56 equals 80. Minus 56 from each side. So 6a equals 80 minus 56, which is 24. Divide both sides by 6, and so a equals 4. So the cost of 1 apple pie is $4. The cost of 1 lemon meringue pie is $14. And I solved all that just by knowing how many pies were sold and the total cost. Thanks so much. Have a great day.